Okay, today we are going to do a few integrals on hyperbolic functions. Suppose we want to integrate let's see. So we have the integral from 0 to 1 of 2 dx divided by the square root of 3 plus 4x squared. We're going to let u equals 2x and a equals to the square root of 3. Then, because u is 2x, du is 2 dx. I'm also going to change the limits, so x equals to 0 implies u equals to 0, and x equals to 1 implies u equals to 2. With these substitutions, this integral becomes the integral from 0 to 2 du over the square root of a squared plus u squared. And this is equals to the hyperbolic sine inverse evaluated at u divided by a as u goes from 0 to 2. And so this is sine, so the hyperbolic sine inverse of u over a is just the square root of 3, as u goes from 0 to 2. Notice that I could have plugged in u equals 2x back, but then I would have to go and put the original limits of integration, so I'm just going to leave it like that. And this would be the hyperbolic sine inverse of 2 divided by the square root of 3. And that's it. Now let's take a look at taking the derivative with respect to t of hyperbolic tangent of the square root of 1 plus t squared. This is equals to the hyperbolic secant square evaluated at 1 plus t squared times the derivative with respect to t of 1 plus t squared raised to the 1/2 power. So this would be equals to the hyperbolic secant square of the square root of 1 plus t squared. And then taking the derivative of 1 plus t squared raised to the 1/2 power, we get 1/2 1 plus t squared raised to the 1/2 power negative times 2t. And this simplifies to t over the square root of 1 plus t squared times secant hyperbolic square of the square root of 1 plus t squared. So that's it for this. Okay, now suppose that we want to find the integral of cotangent hyperbolic of 5x with respect to x. Well, this is equals to, you can write that as cosine hyperbolic of 5x divided by sine hyperbolic of 5x dx. Now we're going to let u equals sine of 5x. Then let me go ahead and erase it because it doesn't, the x doesn't look good. So I don't know, somewhere here in parentheses I'm going to let u equals sine of 5x, then the u will be, so this is a hyperbolic sine, then du will be the hyperbolic cosine 5x times 5 dx. And so plugging all this into the second integral there will give us the integral of 1 over u du times 1/5. Integrating that, we get 1/5 times the natural log of u and absolute value plus c. And then we substitute u back, so we get 1/5 times the natural log of the absolute value of sine hyperbolic of 5x plus c. Now, suppose that we want to find the integral from 0 to 1 of hyperbolic sine square of x dx. Well, we're going to use the following identity for that, which is cosine hyperbolic of 2x minus 1 divided by 2. And we're going to integrate that with respect to x. Bringing that 1/2 out, we just get the integral from 0 to 1 of cosine hyperbolic of 2x minus 1 dx. And then that gives us 1/2. The integral of cosine hyperbolic is sine hyperbolic of 2x divided by 2 minus x, as x goes from 0 to 1. And then plugging in the 1 there, we get 1/4 because of the 1/2 and the 1/2. Sine hyperbolic, I keep forgetting the hyperbolic, sine hyperbolic of 2 minus 1/2 And then when you plug in 0, you get 0. So you get that. Finally, suppose that we want to take the integral of, so from 0 to the natural log of 2. We have 4e to the x hyperbolic sine of x dx. This time we're going to write the definition for the hyperbolic sine. So we're going to have the integral from 0 to the natural log of 2. 4e to the x, and then sine hyperbolic is e to the x minus e to the minus x divided by 2. And then we're going to go ahead and try to integrate with respect to x. Doing that, we get the integral from 0 to the natural log of 2. 4 divided by 2 will give us 2. So we have 2 times e to the 2x, whenever we add those exponents, minus 2. And then integrating that, we get 2 e to the 2x divided by 2 minus 2x, as x goes from 0 to the natural log of 2. Okay, so this, plugging in the natural log of 2, we get e to the 2 times the natural log of 2 minus 2 times the natural log of 2 minus 1, because when you plug 0 for x on e to the 2x, you get e to the 0, so you get 1. Putting all that together will give us 4, because e to the 2 times the natural log of 2 is 4, minus 2 times the natural log of 2, minus 1, and then 4 minus 1 is 3, so this would be 3 minus 2 times the natural log of 2. Okay, next time we're going to do some more integration. Thank you. Bye-bye.